Sierra Space is finally launching Dream Chaser. Yes, you heard it right. Hey, I'm Lucas. Welcome to the SpaceX community. Let's get started. You know, Sierra Space is taking significant strides in the development of its modern spaceplane, Dream Chaser, with a vision to transform space travel into a routine and reliable endeavor. Slated for its first launch in 2025, the program's progress has reached a pivotal stage as the final assembly and testing of its first test vehicle, Tenacity, near completion. At the heart of this innovative spacecraft lies its heat shield, a critical system that will determine its ability to safely re-enter Earth's atmosphere and maintain a high-frequency launch schedule with minimal refurbishment between missions. Even as Tenacity approaches readiness, Sierra Space is already working on an upgraded thermal protection system, TPS, for its next test vehicle, Reverence. This dual focus on immediate readiness and forward-looking improvements reflects Sierra Space's commitment to innovation and operational excellence. Currently, the finishing touches are being applied to Tenacity, including the installation of its final heat shield tiles. Since the inception of the Dream Chaser program, the TPS has been a focal point, and for good reason. The heat shield plays a central role in ensuring the spacecraft's durability during atmospheric re-entry and its ability to quickly prepare for subsequent missions. A well-designed heat shield can greatly impact the turnaround time, operational costs, and overall efficiency of the spacecraft. Sierra Space recently announced that the second Dream Chaser spacecraft will feature an entirely new type of heat shield, developed in collaboration with Oak Ridge National Laboratory, ORNL. In a recent tweet, Sierra Space revealed, Sierra Space and the Oak Ridge National Laboratory are collaborating on a groundbreaking new technology that will enable exterior spacecraft tiles to withstand the high temperatures of re-entering Earth's atmosphere over multiple missions. This announcement highlights a significant advancement in thermal protection technology. Designed to meet the evolving demands of the commercial space industry, the new TPS represents a breakthrough in material science and engineering. Unlike the Space Shuttle's TPS, which was designed for a maximum of 5 missions per year, Dream Chaser's next-generation heat shield aims to support far more frequent launches, aligning with the fast-paced nature of modern space exploration. Sierra Space's approach builds upon over 3 decades of experience from NASA's Space Shuttle program, while incorporating cutting-edge materials and manufacturing techniques. Dream Chaser's existing heat shield features approximately 2,000 tiles, a stark contrast to the more than 20,000 tiles used on the Space Shuttle. This significant reduction in the number of tiles reflects improvements in design efficiency. Additionally, Dream Chaser's tiles are 10 by 10 inches, considerably larger than the Shuttle's 6 by 6 inch tiles, which allows for quicker installation and maintenance. Despite their larger size, these tiles meet rigorous micrometeoroid and orbital debris (MMOD) protection requirements, ensuring the spacecraft's safety during its descent and runway landings. The Dream Chaser team has prioritized making its tiles stronger, lighter, and more cost-effective compared to earlier designs. I'd like to quickly remind you to subscribe to our channel if you haven't already. We regularly upload informative SpaceX and space news videos that you won't want to miss. Be sure to turn on the notification bell so you're notified whenever we release new content. Modern manufacturing methods have enabled Sierra Space engineers to enhance the tiles' durability while reducing their weight. These improvements directly address some of the challenges faced by the Space Shuttle program, such as the susceptibility of tiles to damage and the time-intensive nature of their installation. For example, during the Shuttle era, each tile required up to 16 hours of curing time, a process that often caused delays. Tiles also frequently detached during flights or ground operations, as seen in the early days of the Shuttle program, when tile issues postponed the launch of STS-1 from 1979 to 1981. By contrast, Dream Chaser's tiles are designed for faster installation and greater resilience, enabling quicker turnaround between missions. This modernized approach is essential for achieving Sierra Space's goal of making space travel as routine and reliable as commercial aviation. While the TPS on Tenacity represents a significant leap forward in spacecraft design, Sierra Space's collaboration with Oak Ridge National Laboratory is set to push the boundaries even further. The next-generation TPS tiles are being developed using a proprietary composite material that combines the strength of carbon fiber with the high-temperature stability of ceramics. This material offers exceptional low-density thermal protection, making it ideal for insulating the spacecraft during the intense heat of atmospheric re-entry. According to Sierra Space's CEO, the new system is a game-changer. Today marks a new era of spaceflight safety technology. This groundbreaking thermal protection system will enable low Earth orbit travel to rival the frequency of commercial air travel in the near future. Our patent-pending TPS is unlike anything ever created and is essential for making routine space travel a reality. The development of this advanced TPS has been divided into two phases. The first phase involved creating and testing prototype tiles, which demonstrated the ability to withstand extreme conditions while maintaining structural integrity. The second phase, currently underway, focuses on more rigorous testing. This includes exposure to ArcJet plasma facilities, such as NASA's ArcJet complex, which replicates the extreme heat and aerodynamic forces experienced during re-entry. These tests are crucial for validating the tile's durability and refining the manufacturing process to lower production costs. The new TPS is set to debut on Dream Chaser's second spacecraft, Reverence, currently under construction at Sierra Space's manufacturing facility in Colorado. Reverence will build on the lessons learned from Tenacity and incorporate the latest advancements in heat shield technology. Sierra Space envisions each Dream Chaser vehicle completing a minimum of 15 missions with minimal refurbishment, making the durability and reliability of the TPS a critical factor in achieving this goal. The Dream Chaser program is part of a broader shift in the space industry toward reusable spacecraft and sustainable exploration. By reducing the time and cost associated with maintenance and refurbishment, Sierra Space aims to lower the barriers to frequent space travel. This aligns with the growing demand for low Earth orbit missions, including cargo and crewed flights to destinations like the International Space Station, ISS. Sierra Space's advancements in thermal protection technology are deeply rooted in the lessons of the Space Shuttle program. The shuttle's TPS was a pioneering system in its time, designed to withstand temperatures of up to 2,300 degrees Fahrenheit, 1,260 degrees Celsius, during re-entry. However, it was also a source of significant challenges. The labor-intensive nature of tile installation and maintenance often resulted in delays and increased costs. Dream Chaser has addressed these historical challenges by streamlining its tile design and manufacturing processes. The decision to use larger tiles, for instance, reduces the total number of tiles required, simplifying installation and inspection. Additionally, the use of advanced materials and automation in manufacturing has significantly improved the tile's performance and reliability. Sierra Space's vision extends beyond the immediate success of Dream Chaser. The company aims to set new standards for the commercial space industry by enabling spacecraft to operate with the frequency and reliability of commercial airplanes. Achieving this goal requires not only technological innovation, but also a commitment to rigorous testing and continuous improvement. As Dream Chaser prepares for its first launch in 2025, the program is entering a decisive phase. The performance of Tenacity during its initial missions will provide valuable insights into the spacecraft's capabilities and identify areas for further refinement. Meanwhile, the development of the next-generation TPS for Reverence will continue to push the boundaries of what is possible in reusable spacecraft design. Thanks for watching today's episode. Don't forget to subscribe and give us a thumbs up if you enjoyed it. Stay tuned for another great video tomorrow.